Hi, welcome to Why Test Automation Works for Non-Programmers. I'm Andrew. I've been in the games industry for about 20 years as a programmer and as a lead programmer. I've worked on a whole range of genres, from management games to action games to racing games and puzzle games. I've worked on a whole range of platforms, from mobile free-to-play to PC to console to back again. And for the last 15 years or so, I've been using as part of my practice test automation inside game development. Test automation is a widely used practice outside of the games industry in wider software fields, but doesn't seem that widely used in video games. And so while I've been doing that, I'm also been talking about that, forming communities around that to try to help people use more test automation. So here's me in 2014 talking about automated testing at GDC. Here's me in 2023 talking about automated testing at Develop in Brighton. And for the last year or so, I've been building a business that helps game studios get started with test automation and with studio DevOps. We'll talk more about that later. But that's who I am. Who are you? You are some kind of non-technical stakeholder. Maybe you're interested in test automation, you don't really understand what it is and how it helps. Or maybe you've been sent this by a programmer on your team who's interested in this subject and wants you to understand it more deeply. But you're some kind of person, like a director or a lead of any discipline. I'm not going to assume, but your QA or your art or design or something. And you want to try and answer this question. Are there cost-effective ways to increase quality on our game? And I'm going to say to you, I'm going to hopefully prove to you by the end of this talk that yes, test automation is a cost-effective way to increase quality on your project. And we're going to do that like this. We're going to discuss the challenges that game dev is facing at the moment. We're going to talk about some of the benefits that automation brings to game development in the context of those challenges. We're going to look at the case studies of some studios that have used test automation to some success, including my own work. And we're going to talk about the costs of automation. Like, if we're going to define the ROI of automation here, what's the actual I that we're investing? What we're not going to do is do a deep dive or a technical tutorial on how to get started with test automation. What we're interested in here is a real high-level view of what it does and how it helps. So let's talk about some of those challenges. You would have seen triangles like this before. You can use it when evaluating any kind of product. I think it's interesting to look at this triangle and drill down into each of these corners to see what it means for game development. And we're going to start at the top there, resources, which is often a large part of your resources is going to be your staffing costs, of course. But there were other factors here, like the limited funding environment we find ourselves in the year of Luigi 2025. And situations like your recoup agreement with your publisher might mean it's easier for you to add certain types of headcount to your project versus other types of headcount. When we move on to look at time in the bottom left, time, if we can ship faster, then that's going to influence stuff like our launch windows. I'm recording this in September 2025, and a whole bunch of people have just moved their launch date out of early September because they don't want to get stomped on by Silksong. And if you can bring that forwards, not just delay it, if you can bring that forwards, you're going to be in a really good position. If you can ship faster, by the time you do ship, you're going to be much more aligned with industry trends than you would be otherwise. No one wants to be the MOBA launching in 2028. And once you have launched, if you can ship quickly, then you're going to have a really good update cadence, which is going to let you respond to your community, fix problems, as well as react to the issues they're having with the game and help address that and really build a strong relationship. When looking at quality on the bottom right, we're talking here not just about how nice are your anims and your mocap, but everything, right? The overall value proposition of your game, which is really, really important when we're facing what feels like an ever-decreasing slice of the pie every time a new game comes out. And a huge factor in standing out is not only your value proposition, but things like your Steam reviews. If you launch with one or two really, really bad bugs, it could hamper your chance of becoming profitable really, really, really quickly. So it's extremely important these days. Not only does a game come out with the right features, but it comes out and it's really stable. So let's do a thought experiment. I want you to, this is an important question anyone running a project might want to ask themselves, is how do we do more with less here? And I want you to pretend that you ask a complete buffoon. You're going to an absolute idiot for their opinion on this question. And I want to be very clear, it's not actual advice. They say to you, hey, looking at your balance sheet, you've got a whole bunch of headcount here who aren't contributing in terms of code or art or design. They're only QA. Why don't we get rid of these people? And you shake your head because obviously you're not an idiot and you know that QA are extremely, extremely important part of game development. But you want to explain to this person why it's actually a good idea that this headcount exists on your project. So I want to go back at that product triangle that we just looked at and look at the benefits, or look at the drawbacks that we will see if we remove QA from the project. So according to Lionel Hutz, if we remove QA, we're going to be happier. Our resources are going to be in a better situation. We're going to have less staff on the project. Fine. Maybe Lionel agrees relatively quickly that your quality is going to go down. If you have no one on the project whose responsibility is the holistic health of the game, then you're going to have things like poor stability. You're going to have bugs in the game that you haven't noticed for a long time that's going to affect things. It's going to make it more difficult for you to judge the quality of your features and iterate. It's going to take you longer to iterate, which is mean you're going to get less iteration into the same time frame, which is going to mean the quality of your game overall, not just like the stability, but how fun it is not going to be as good as it could be. And another factor on that is you can't playtest as early as you otherwise could. You have to wait until you've really discovered all those bugs by yourself. And you're getting that playtest feedback much, much later in development, which is much less useful. You can't react as strongly as you could if you got that feedback earlier. So all of these things are driving down quality. But what's going to happen in the bottom left? What's going to happen to our time? I'm going to argue that it's going to get worse because old bugs are more expensive. And we're going to think this through. Old bugs are more expensive for a bunch of reasons. They're slower to fix. If you give a bug to a programmer and ask them to fix it, but they haven't touched that system in 6 to 9 months, it's just going to take them longer to figure out how did this system work? What are the best practices here? What does the best, most stable fix look like? So it's going to take them longer to do it. But also it might be more complicated. You might find that when the programmer comes to fix the problem, if they had known about this when they were architecting the entire system, they would have been able to take a different approach which allowed them to fix this bug much more elegantly. And now it's going to be way more complicated. Not only that, but there might be entire systems that depend on the way this bug behaves. And so there might be knock-on effects for making this fix. Furthermore, there'll be buried bugs. If the game is crashing on level 4, then you're not actually going to have a very good understanding of what kind of bugs exist on level 4 yet. And so just fixing this one bug might reveal more bugs. And that's not a great thing to be doing very late in a project. And not only that, but every day a bug exists in your project, there's disruption to others. It might be that people really want to be working in level 4 right now and they can't because there's that crash there. It might be that there's some kludgy workaround they have to do to use a certain tool that's really buggy right now. So you're paying that cost every single day the bug exists in your project. So that fact alone makes old bugs more expensive, let alone the other stuff we talked about. There's a good metric you can use for this stuff called mean time to resolve, MTTR, which is just the average time on your project, the average time between a bug being created and a bug being resolved. And I think it's really interesting for you to look at your own project right now and try and figure out what that MTTR is and see if there are things you can do to bring that down. I think in many ways, it's almost as interesting a metric, maybe even more useful in some situations than overall bug count. So knowing that if our MTTR is really long, we have bugs that are really, really costly to fix, that's actually going to cost us time. So removing QA from the project has made to ship the same game is going to take us longer. And not only that, But I want to reevaluate our core assumption here that our resources are actually better off, because fixing those MTTR bugs is going to waste a tremendous amount of expensive programmer time. And other disciplines, like we mentioned, are going to be impacted every single day when there's a large amount of old bugs in the project. And we know this. I think we know this intrinsically because no one really questions the fact that we should have QA on the project. So I want to go back to Lionel and say, no QA. I mean, you know, this joke was coming. No QA. It's one of those counterintuitive things to the outsider. This is why I wanted to go through this thought experiment. Because adding headcount to the project, adding expense to the project actually ended up saving us in all three corners of the thing. Because sometimes you've got to spend money to make money. It makes sense. These things can be no-brainers. And speaking of no-brainers, I'm going to talk a little bit about what test automation is. I'm aware you might not really understand what I'm talking about. But before I do that, I want to make super, super clear, especially in the context of the discussion we've just had, that automation is not a replacement for QA. It's not about getting rid of every single QA person on your project and replacing them all. Every single project that I've implemented automation on, QA has been really, really happy with the end result. And you see why, as we go through this talk, the benefits that they will see alongside everyone else. Let's get to give you a high-level definition of test automation. Let's say that test automation is code that automatically and accurately verifies a feature's behavior. If we break that down, then we can see we've got code there. Someone's going to be writing a small program. Normally we call it a test, a small test. Maybe they're using a visual language here rather than, you know, classic C++, C#, but they're going to be creating a small piece of program that interrogates either your entire game or a subset of your game. And it's going to do that automatically. You should have a build server. If you don't have a build server, that's something I can help you with as well. But this is a fantastic place for putting automation, to having it run on a really rapid cadence. Once a day, multiple times a day, every time someone pushes, you've got a bunch of options here, but getting feedback really, really, really quickly so we can action test failures as quickly as possible. And we want those test failures to be really accurate. When a test fails, we want to know that it's failing reliably. Like, we don't want a test that is flaky and fails half the time and passes the other time. And we don't want a test that fails even though the code is actually working, or vice versa, the test not to fail when the code is actually broken. This is where often people fall down with test automation. They see a certain number of tests in the project and think they're doing well, and then very quickly, 6 months down the line, discover that they're in a terrible place because they haven't got accuracy inside their tests. And then finally, verifies behavior. If you're familiar with QA lingo, you know the difference between verify and validate. Test automation often falls on the verify end. That means what we're testing here is that the system that was created works as it was intended when it was created. Whereas the validation end is more like, did we even choose the right system to create in the first place? I'm going to look at some examples of automated tests. In terms of common bugs that you will have seen on projects that you've worked on in the past, I'm sure, I know I have. Things like we talked about before, level 4 doesn't boot. I talked to someone recently working at a publisher who would set up a playtest for one of their development teams, got people in to play the game, to get feedback, and the development team had sent a build over and they booted the build up and it couldn't actually boot the first level. This is something that's going to slow down your entire team, waste a whole lot of money, waste a whole lot of energy if your build is in a situation where it can't actually play the actual game. A mesh on level 6 is missing a texture. This is a great example of something that wouldn't actually block a playtest or something. But if we can just inform the artist right at the point where they've just pushed and they've forgotten to commit a texture. And if we can just inform them straight away, hey, you've forgotten that texture, then it's so much easier for them to fix that than it is for us to task a QA person to go and examine a whole level bit by bit and try and spot every single missing texture and then log that and then get that list to an artist weeks later when they're in the middle of some other task. It's just so much quicker. Being able to load old saves. This is important post-launch, but actually quite important during development as well, especially for games with big metas. And it's something that's really fiddly. You have to go and find all those old saves. You probably have to put them in the right place on your hard drive and then boot the game in a certain way to get it to load that save, just to test that you've added the right parameter in the right place. Instead, we can have the server just run through a couple of checks. And then very quickly, when a programmer adds a new property to the save game, then we can inform them really quickly and say, hey, you've missed off. This doesn't work with save 0.2 because you've missed this thing, and you can add it. At a more functional level, banana peels not colliding with carts, which should be something QA can spot, and they probably would spot it. But if they're focused on, say, trying to spot missing textures, then it might be relatively easy for them to miss the fact that a cart just happened to clip through a banana peel without reacting. So we can automate that kind of thing on the server. What we're not talking about here is that automation brings 100% confidence that a feature is bug-free. You definitely still need that ingenuity from QA. You need that insight where they can holistically view the project and attack it from a whole bunch of angles. That's an extremely important part still of making sure that a feature is bug-free. So let's apply that to our product triangle. If test automation is running regularly, if it's giving us feedback on some of those real awkward problems that we just talked about, then our MTTR is going to be low. And so we can have confidence that we're going to ship faster if we can use test automation effectively. And if test automation didn't improve quality, then I don't know why I'm even giving this talk, but it does improve quality. It improves stability across the board. The fact that we can be loading those old saves, the fact that we can make sure level 4 is constantly bootable, means we can do stuff like earlier playtesting and get into that virtuous cycle of getting really early feedback and improving on that, and then validating that you've got that, you've reacted to that feedback correctly. And we can use that safety net of test automation alongside QA to let us make really deep changes later into development, which relieves QA of all those monotonous tasks of having to boot every single level, of having to look for missing textures. Instead, they can focus on what they're really good at, which is destructive testing, which is exploratory testing, which is qualitative feedback, which is finding those hard to find repo steps. But what about the last corner? Are we going to have a happy face or a sad face for resource usage? Because there has to be a cost for this stuff, right? And not only there's going to be a learning curve, of course there's going to be a learning curve. If only there was some handsome test automation consultant who could help with your learning curve. But at the end of the day, someone's going to be creating tests, which we've established are little pieces of code, right? It might be, again, it might be a visual tool, but someone's going to be writing code here. And writing code is expensive. However, when you factor in all those other aspects that we talked about, like the smaller MTTR, it's very possible that you come out without an overall productivity hit. That's true in my experience, and also in the literature. There's been numerous studies looking at this. None of them have found a productivity hit. This exact study compared test-driven development, which is a specific flavor of test automation, compared that to a control group over 6 months, both working on the same problem, and they found that the team using test-driven development was able to find more defects, but was exactly as productive. And that might seem counterintuitive to you. So let me have one more go at explaining why it's the case. And I think a large part of that comes down to different definitions of done. This is a classic life cycle of a feature that I'm familiar with from early in my career. And when someone asked me, hey, how long would that feature take until it's done? I would often give them this date, kind of ignoring the fact it would be this implicit assumption for everyone in the team that there will be a massive amount of bug fixing later, right? And we'll just get through that. But for done, air quotes done, it was here. And if you compare that directly to working on a feature with automation, it's going to take longer, right? Because you're going to be writing tests. It may well take a little bit longer. But at that far end, that bug fixing is going to be much, much, much smaller. Because you'll find bugs earlier on, which are easier to fix. And you'll also have that safety net to help you make rapid changes later on. And we can put these together and you can see how if we have the same measure of done for both things, then actually with automation can come out better or the same. And not only that, but we can do things like, because we're going to have less bug fixing, we can move our beta line much further back into development, which means we can get more features in. We can get way more features in. And not only that, but after beta, we can be doing safer, deeper changes because we've got that test automation to help us and to react quickly if we make a problem. So with all that in mind, with the fact that literature shows that we don't have an impact, with the fact that if we evaluate definitions of done, it's easy to see how they might be the same, I'm actually going to say overall your resources will be the same or better. Someone is writing tests, but you're going to spend less time on bugs, which is going to be better overall for everyone. And so that's why I think test automation is the same kind of no-brainer as QA. And notice that none of this has been contingent on team size or on budget. I think everything we've talked about so far can apply to almost any team at any scale. And let's look now at some teams that have used test automation successfully and what kind of benefits they saw. If you know anything about test automation, one of the first games that will come to mind is Sea of Thieves from Rare. This is a talk from Jess Baker at Unreal Fest in 2019. Robert Masala also used a very similar slide in his talk at GDC in the same year. In test automation circles, we call this the slide because of how plainly it paints the improvements that Rare saw from using test automation. That very familiar white line that I'm sure you're familiar with as well, of bugs piling up and up and up on Banjo-Kazooie nuts and bolts until you hit alpha, and then you're like, okay, let's start fixing things. And you death march and you crunch to try and get through things. But Sea of Thieves never hit the same bug count that Banjo-Kazooie nuts and bolts had at launch. And because of that, they had all these knock-on benefits where they could ship really, really, really quickly because they had low bugs, low MTTR. And they had test automation to help them ship. They would choose on Friday to ship, and then on Sunday that build would be live to beta testers, and then later on to the general public. And I've worked on projects that have taken much smaller projects that have taken 2 weeks to sign off on a build. So for them to be able to do that in 3 days is really remarkable. And they get all these extra benefits on top of that, because if they can ship more quickly, then they can react to their community more quickly. They can fix serious bugs more quickly and more safely. And they can iterate on features more quickly with feedback from the community. So tremendous driver here, not just of a lack of bugs, but on overall quality of the game in general. And they're doing this at Rare using what's called feature team automation. That is the team that's creating the features, the systems. They're also creating the tests alongside those features. And that's in contrast to our next case study, which is RGG. RGG is a Sega studio who work on the Yakuza games, amongst others. They're a 2-project studio. But you can see from this list, they're shipping, it seems like each team is shipping every single year. And those Yakuza games are not small. Like a Dragon is not a small game. It's open world. There are tons and tons of really deep mini games with lots of custom assets and custom logic. But they're still able to ship really, really quickly. And part of the reason why they're able to ship quickly was revealed in this article on Automaton website, which is a games journaling website. Despite the name, it's nothing to do with test automation. But they talk to the QA engineers who work at RGG. QA engineering is a different discipline to feature team engineering. Here, the idea is that the feature team basically implements systems as they have always done. And then the QA engineering team builds high-level tests around the game as a whole, maybe diving in on individual systems and features now and again to structure tests around them. But mostly they're focusing on looking at the entire game. And this team of 3 QA engineers were able to, like a Dragon, able to construct 700,000 hours of test runs on Infinite Wealth, 700,000 hours of test runs, which resulted from only 5,000 hours of development, which effectively means one dev gave 1 hour of dev time gives you 140 hours of testing. when it's running on the automation server. And this is not just like sitting there doing nothing, right? They found 60,000 bugs this way, which represents 80% of the total bugs of the project. Bugs that were found really quickly, fed back to the feature team really quickly. They could resolve really quickly and see that time benefit. Look at that. Like, I mean, it's obvious where that time benefit is coming from here, right? When you're getting 140 hours of testing from just 1 hour of investment. And that doesn't mean that QA was sitting there twiddling their thumbs. They were finding that 20% of bugs that are really, really hard to find, the ones that are really hard to automate. So they're still contributing a lot to this situation, but you can see the time benefit and you can see how this feeds into them being able to ship so quickly. Finally, let's talk about a project I led, Rollerdrome. If you don't know anything about it, Row 7, 2022, Tony Hawk's with guns. Really good game, over 1 million downloads, won a BAFTA. That's me in the top right with the yellow hat. And we, because it is a video game, had exploding barrels. And QA found one day that one barrel in one corner of one level did not explode. That bug went into the database. It eventually came to a programmer, and it turned into one of those extremely rare 5-minute fixes. It was just on the wrong physics layer, which is a very easy thing to fix. It's a very safe fix. It's very easy to understand why it happened in the first place. And so it's a true 5-minute fix, which, like, if every bug was like this, then shipping games would be so much easier. But while the programmer was really excited about this actual 5-minute fix, QA are shitting themselves because they now have to go and explode every single barrel on every single level and see if this is happening anywhere else. Not only that, but they have to do this before every major external release. And not only that, but they have to rely on design to tell them when they add a new barrel to the game, because they might have hidden it in some corner somewhere and it might be easy to miss. So we've just suddenly added a whole load of stuff to QA's plate for them to look at this. And this is how projects get into the situation where, you know, it takes QA 2 weeks to sign off an external build because they have to go through all these checklists. And if you want to solve that problem, you might throw more people at it. You might increase your resources and parallelize this. Maybe you get, an external QA contractor of 15, 20 people to look at your game through beta to really make sure that it's got as few bugs as possible. But while the programmer was adding that 5-minute fix, he was also adding a 5-minute test that very quickly checked to see if there were, if every single barrel on every single level had the right physics layer, which meant the QA never had to go and explode every single barrel. And on a 25 headcount project, for most of the time, we had only one QA. At the very, very end, we had ramped up to 3. But we never found the need to go to that external warehouse of 15, 25 QA people for a month or so to get that final validation on the project because we had that automation saving us on those resources. And because this is my project, I can go into way more detail here. So we can look at time as well. Let's look at another success story from using automation. This, like I said, it's a bit like Tony Hawk. So there's lots of different things your character can be doing, lots of different states for the character controller to be in. They can be grinding or wall riding or verting or flipping or tricking or jumping, air outing, acid dropping, all these different things. And that meant when I joined the project just before Greenlight, we were in a situation where the character controller was quite fragile. Anytime we added a feature to the character controller, QA would come back 2 weeks later and say, oh, you touched grinding over here, which means wall riding has now got a bug in it. And we had 6-week milestones that we were doing before every external release. And we couldn't reliably debug the character controller fast enough for us to keep working it all the way up to the end of that 6 weeks deadline. So we had a feature freeze. For the last 2 weeks of the 6-week milestone, we wouldn't work on the character controller to give QA time to find the bugs, which is kind of untenable. This is Tony Hawk with guns, right? Essentially 50% of the game is the character controller. And we're saying you can't work on it for 1/3 of your dev time. And so we started instrumenting test automation around just the character controller to begin with. It was very modest. We're just going to look at the character controller and start using test automation, and very quickly became one of the most stable parts of the game. And it ended up looking like this. This is recorded from my Develop 2022-2023 talk. This is the character controller running through a bunch of different edge cases that it wants to check, a bunch of different bugs that had happened that we had then validated with test automation. And that made it extremely, extremely stable, to the point where it was maybe the most stable part of the game. And we could make really deep changes on this very late into development, like deep optimizations on the character controller. There was at no point did we have to say, we can't fix it. It's too risky to fix this bug, because we had that safety net of the automated tests to help us. And this is my attempt at the slide, but for Rollerdrome, this is serious bugs in the character controller in the last 9 months of development. And I don't know if you can see the y-axis there, but it says 3 is the highest number. And these are not open, these are not bugs created, these are open bugs. Okay, so you can see that MTTR being really, really low here. In November, we found 3 QA-facing bugs in the character controller, and we fixed them almost immediately. We had 9 months there where there were no serious QA-facing bugs in the character controller. And I promise you we were working on it. I promise you we were adding features and fixing bugs. But the tests were just capturing that stuff really quickly and letting us fix it really quickly and really safely. And that meant that 2-week freeze we had to put in place, we could get back. And you can see, like we were talking about before, how adding QA to a project is a no-brainer. Adding test automation here, in hindsight, was a no-brainer. It could have added 1.5 weeks per milestone of adding test automation. It could have cost us 1.5 weeks, but we still would have gained back that half a week extra of dev time. And we ended up shipping on time and on budget because we didn't have to descope the character controller or extend the budget, extend the timeline in order to fit in the extra time that we had lost from our 6-week milestones. So huge benefits to time here, and also huge benefits to quality. These are all metrics from memory, so I'm pretty sure they're accurate. But to remind you, it's a 25-person-ish project, which includes 3 QA at the end. But we had, on our worst day in the lead up to beta, we had less than 10 serious bugs in the project, which my senior producer continually said was remarkable in his history of working on projects. On our day with the most bugs open, we had 600 open, but we already had 2,400 closed, which represents 80% of the bugs in the game were already fixed. Which means we never faced that Banjo-Kazooie nuts and bolts style slog death march to get through the last bugs before the end of the project. Now, I'm not saying that automation is the only reason this happened. We had a quality first mindset. Everyone owned quality throughout the whole project, but automation was a factor in letting us embrace quality like this. So I hope you can see we had just win-win-wins across Rollerdrome. But let's talk about some of the things you have to consider when you're starting test automation, when you're investing in this. So it's a process change, obviously. That's never going to be cheap. You know this, but if you get the right help to get you over that hump, then you can make it smoother than you could otherwise. You do need technical buy-in. If you're a non-technical stakeholder and you found this talk by yourself, please forward it to your engineering team. And you do need training. But the level of investment here can scale. It doesn't necessarily have to represent an enormous change. You can get quite a lot of bang from a little buck here. If we look at this, this is my vague estimate of the level of investments in the case studies we've talked about, starting with Rollerdrome, where you can see we never hired any extra headcount to deal with test automation. We had some training involved, which was mostly just me teaching people on Zoom calls, pairing with them, code reviewing now and again. It didn't seem to impact our productivity that much. And I hope you can see that even within that one project, just from the character controller stuff alone, it paid off massively. Like a Dragon, I said that they had 3 QA engineers. They started with 1. They started with 1 QA engineer. So that was extra headcount. But they saw that benefit enough that they've scaled it up to 3. And now they're talking about working with the wider Sega organization as well. So they're definitely seeing the fruits of that investment there. Sea of Thieves, a big investment. I'm not going to lie with that one. They had expansive feature team automation testing, across every system of the game, which required a lot of training. But I still think, from looking from the outside, that paid off for them, that they produced a solid quality product, and they saw all those benefits of being able to ship fast and be able to engage with their community. So I still think they got that payback within that one project. But as you scale up your investment, you are going to face bigger and bigger challenges here. And this is where the sales pitch slide comes in. So I want to talk a little bit about what my company does. We do consultancy, first of all. So we'll come and we'll talk to your stakeholders, discuss the risks on your project, the challenges you're facing, and then make recommendations for how you can add test automation in an effective manner to your project. Not only that, but we offer fractional build engineering. So if there are certain studios you don't necessarily have the scale where it justifies having your own build engineer, and maintaining your build server is a drain on your other resources. So in that situation, we can come in and we can help. When it comes to training and getting people on board with new processes, we do multi-day workshops with your team where we go over stuff like tooling. You may be surprised to learn that Unity and Unreal already have expansive test automation tooling inside, ready to go. You don't need to pay an extra license fee for anything here. There's stuff you can already be using day to day. And we'll go through the best practices of using that tooling and applying it to your project. And we're going to, in that workshop, add tests to your project. So even if you do the workshop and then something else comes up, you forget about it entirely, you never touch test automation again, you'll have some valuable tests from those few days of workshops that will give you value for the rest of your project. Recently, we've started opening this up to anyone who wants to buy a ticket and come along and do a workshop. You should check out the website to see if there's one coming up right now. And then finally, we also do fractional QA engineering. So if you were interested in adding RGG style QA engineers to your project, so you didn't have to change the processes of your engineering team too much, but you didn't necessarily want to invest in a whole QA engineer or bother with the overhead of trying to hire the correct one, we can deal with that as well. So wrapping up what we talked about today, we've talked about that old bugs are bad. They're more costly to fix when it comes time to actually fix them. And then you'll also be paying an overhead for every single day they live in your project. And automation helps find things faster because they're verifying the work that you've done on a rapid cadence on the build server and giving you informative test failures to help you react to that information really quickly. And although there's a learning curve, once you get over that learning curve, you can see benefits across the board. You can be shipping faster, better, with no resource increase. Because I hope you agree with me now that test automation is a cost-effective way to increase quality. Thank you very much.